Now we come to the last question of 2024 AMC 8, which is generally the hardest question for the whole set. So let's take a look. A small airplane has 4 rows of seats with 3 seats in each row. 8 passengers have boarded the plane and are distributed randomly among the seats. A married couple is next to board. What is the probability there will be 2 adjacent seats in the same row for the couple? For this question, I'm going to assume you already know something about combination, like 12 choose 8, all those sort of calculations. If you don't know those things yet, you can check some of the early counting related questions, which is understandable because, again, question 25 of AMC 8 is very, very difficult. All right, now let's take a look. Again, I'll quickly go through some concepts, but if there are some definitions you find you're not familiar with, check it out from earlier questions. First thing, what is the probability that the 2 adjacent seats in the same row for the couple? The first question is going to be, how do you calculate probability? I'm going to call it prob. So probability equal to how many ways can you assign the seats? So number of ways of possible seats for those 8 people. That's your universe, meaning I have 8 people that's already boarded the plane. How many ways can I just put them into different seats? That's your universe. Now, for some of them, some of the cases, there will be 2 adjacent seats in the same row. So it's going to be the number of cases with adjacent seats. So ADJ seats. You can generalize it to probability equal to number of cases that satisfy my requirement divide by all possible cases. So let's do this step by step. The first part is going to be, I have 12 seats. 8 passengers have boarded already. How many ways can I put them into different seats? The answer here is going to be, so number 1, step 1, number of possible seats arrangement. How many ways can I choose 8 seats out of the 12? So for this one, the answer is going to be 12 choose 8. It's a typical combination question. Combination. And combination question generally is defined as, I have 12 things, you need to pick 8 of them with no restriction, randomly. How many ways can you take it? And the equation of this is 12 factorial divided by 8 factorial times 12 minus 8 factorial. Here, factorial means, as a bracket, 12 factorial means 12 times 11 times 10 times blah 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 times 1. So if you do this calculation, you can find there are 495 cases. That is your universe. So altogether, we have 495 ways to say those 8 seeds are taken. Now we need to go a step further to say how many of them would work, would have 2 adjacent seats in the same row for the couple. So this is a question where I need multiple slides. I'll move to the next slide because I need more space to write out the solution. For this one, we have four rows of seats. So one, two, three. One, two, three. One, two, three. One, two, three. Now you need to count how many cases will make this work. And it's a fairly complex scenario, right? Because 8 people, you will need to cross over 8 seats. So we will need to use casework. Again, for counting, casework is used to make sure you do not miss any case, and you can simplify your life a little bit by saying, hey, look, I know there are many ways to make it work, but they belong to those cases. There are different ways to set up your cases. For this question, what I recommend is going to be, we have 4 rows and we have 8 people. So you can start from how many people are there for each row to define your cases, which means I'm going to write 8 to be equal to different numbers plus together and figure out for each case how many of them will have 2 adjacent seats in the same row. All right, now we have 8 people and you need to divide them into 4 rows. What's the first case coming to your mind? Well, the first case is going to be 2 plus 2 plus 2 plus 2. This is an interesting case because if you do have 2 people in each row, how many of them or how many possible constructions will have adjacent seats? You'll quickly find the answer is 0. So number of cases ADJ. I'll just make things easier. Just say, hey, number of cases with adjacent seats. So my first case for those 8 seats is 2 plus 2 plus 2 plus 2. And that's an easy one. There's no case under this case or under this scenario that would ever work, that would ever have 2 adjacent seats. So for this case, it's 0. Case 1, number of scenarios or arrangement that works is 0. It's not possible. Now let's think about case 2. And here you probably get a point. The way I will construct my case is going to be, I have 8 people. How many people are in each row? So 2, 2, 2, 2 is done. What's the next case coming to your mind? Well, 8 can also be written as maybe a 3 plus 2 plus 2 plus 1. So the scenario is going to be one row, all 3 seats are taken. Second row, 2 seats are taken. So 3, 2, 2, and one row is 1. We'll figure out how to do the counting. So you probably have a question to say, how do you know it's a last row with 3 people and the first row is 1? I don't. And we'll figure out how to count it by permuting those rows. But let's figure out firstly, will this ever work? Well, the answer is the row is 3 people, no way. The row is 2 people, no way. But if you only have one person in a row, as long as this person is not in the middle, so either here or here, things can work out. So there are some cases or some possible arrangement which we'll see. Number of ADJ. So how many possible ways can you make this work? Let's do this step by step. So for each row, for this row with one person, I have two ways to put in this person. You can't put this person in the middle, but you can put it either here or here. So I have two options. Here again, how do you do the counting? You find for each step how many options you have, and you multiply them together. Now, for this row with two people, how many ways can I put two people in a row of 3 seats? There are 3 ways. Either here, here, or here, here, or here, here. Or this is actually equal to 3 choose 2 if you're familiar with combination. I have 3 seats, I need to pick 2. Same thing for the next row, 3 cases. Last row, there's no choice. Every seat is taken, so just 1. Okay. Now, remember, I don't really know which row has 3 people, 1 person, or 2 people. So I also need to figure out how many ways can I just rearrange those rows. Well, how many ways are there? I can see, firstly, you need to pick a row with 3 people. I have 4 choices. So 3 people. And then I need to pick a row with only 1 person. Well, I have 3 rows left, so I have 3 choices. Okay, so one more time. There are many numbers. We will need to multiply all of them together. So I want to make sure we understand why each of them is option. For the row with 1 person, I have 2 choices on where this person can sit. The row is 2 people, I have 3 choices. Another 3, and then there's a row with 3 people, all seats taken, so only 1 choice. But now I need to permute those rows because I don't know which row has 4 people, 4 choices, and a row is 1 person, 3 choices. Multiply all of them together, you will get, so this, for this case, there are this is equal to 27 times 8, which is equal to 216 solutions, or 216 cases that work. Okay, so this is a good one. 3, 2, 2, 1. There are 216 scenarios or possible solutions that would work. All right, before we move to the next slide, we have 8 equal to 2 plus 2 plus 2 plus 2, 3 plus 2 plus 2 plus 1. What's left? Well, you can also do 8 equal to 3 plus 3 plus 1 plus 1. So that's my case 3. I want to have all the cases listed out here before we do the actual calculation. So you can check to make sure I didn't miss anything, because there are just so many ways for you to write 8 equal to different numbers plus together. What else? Well, one more case here is 8 equal to 3 plus 3 plus 2 plus 0. All right, next slide will be look into the remaining 2 cases. And look at those 4 cases and think about this for 20 seconds-ish, just to make sure I didn't miss any other way to write 8 equal to 4 numbers add up together, and each number cannot exceed 3. All right, now case 3. 8 equal to 3 plus 3 plus 1 plus 1. So same thing. 1, 2, 3, 4. This row, all seats are taking 3. This row, all seats are taking 3. And then this row 1, this row 1. Now we need to do calculation one more time. So you can find for the row with 3 people, again, you don't have a choice, just 1. For the other row with 3 people, just 1. Now you have 2 rows with 1 person only. So this actually gets tricky because remember, how many ways can you put 1 person? It depends on whether you want adjacent seats for this row, because now you have 2 choices. So this case actually have some subcases. What do I mean? Subcase here means either the first row works and the second row doesn't. So there's a subcase. That is, the first one works, second one doesn't. There is also a case where first one doesn't work, second one has adjacent seats. Or you could have both row works, or both rows work. And we need to add up those subcases. So let's take a look. In this case, I'm going to have, because it works, so, I have 2 ways to put my single person. And for this case, if it doesn't work, that means someone is in the middle, so 1. And similarly, if the first row doesn't work, a person is in the middle, and the second row, I have 2 choices. And finally, if both rows work, that means for both cases, the person picked the side seat. So it's going to be 2 and 2. And then you actually need to add up those cases. So for our case, it's going to be 2 times 1 plus 1 times 2 plus 2 times 2. And this is going to be equal to 8 cases. That's why this question is tricky. And that's also why I go to case 3 later, because you need to consider subcases. And again, you need to make sure they don't overlap. First one works, second one doesn't. First one doesn't, second one does, and both work. Now, same thing. We don't know which row has 3 people and which row has 1 person. So you need to pick 2 rows out of the 4 to have 3 people. So now you also need to multiply this by 4, choose 2, which is equal to, so number of ADJ here is equal to 8 times 6 equal to 48. This is the most complicated case, by the way, because case 4 will be easier. Case 4 is 8 equal to 3 plus 3 plus 2 plus 0. So same thing. 3 seats are all taken. So now this one has 2 seats being taken and 0 seats. So you have a row which is totally open. For this one, again, 3 seats, 1 choice. 3 seats are taken, 1 choice. You don't really have a choice. For the row with 2 seats taken, you have 3 ways to put 2 people into 3 seats. And finally, this open row, only 1 choice. And this will always work because this open row will have 2 adjacent seats. So in this case, this is going to be number of ADJ, which means the cases that work, is equal to 3. So 1 times 3 times 1 times 1 is 3. And again, we need to figure out how the rows permute with each other. Which row is 0 people? Well, you have 4 choices for the row which is open, and you have 3 choices for the row is 2 people. So altogether, that's 36. All right, last thing. We have 4 cases, so the total number of ADJ, so total number of cases that work, is going to be equal to all those cases add up together. Case 1 has no choice that work. Case 2 has a lot of choices. Check your notes, it's 216. Case 3 has 48. Case 4 has 36. So add all of them up. You will find for 300 cases, this would work. And your total population, the universe, is 495. So the probability equal to number of ADJ, the number of cases that work, divided by number of total. So you just take 8 seats out of 12. This is equal to 300 divided by 495. Now you can cancel the number. You'll find this is equal to 100 divided by 165. Divided by 5, you'll get 20 divided by 33. So the answer, 20 over 33. That's the last question. Definitely the most difficult one.